Lesson 3.2, Add, Subtract, and Multiply Polynomials. In this lesson, we'll add and subtract, we'll multiply, we'll compare polynomial functions, and we'll write polynomial functions. Anytime you combine like terms, what you're looking for are terms with the same variable and exponent. Variable, there we go. For example, you could combine an x squared with an x squared, but you cannot combine an x squared with an x to the third. They're different exponents. Anytime you're asked to add or subtract, adding is what you can do to just drop the parentheses right away and combine like terms. So adding is usually the easier of the two. If we have 6x cubed, I'm going to put plus x squared second plus 4x minus 7. I just wrote it in standard form. And then I'm going to add 2x cubed minus 8x squared plus 3. If I look at combining like terms, I notice I've got a 6x cubed and a positive 2x cubed. Together they would make 8x cubed. And then I look at, I've got 1x squared here minus 8x squared from that other polynomial. The coefficients 1 minus 8 would be negative 7. Noticing that the plain x term, there's a 4x in the first parenthesis, but none listed in the second, so I just write that term. And then last but not least, we have our constants of negative 7 plus 3 for a value of negative 4. That's when you add the polynomials together. Now when you're asked to subtract, make sure to distribute that in first. Otherwise you might miss a change in signs in that second polynomial. So now let's look at, we've got 3x squared, y squared, plus 2xy squared, plus just 6x squared. So now if you distribute that negative in, the two negatives make a positive, so there's positive 6x squared y squared. But then that negative makes the next term negative 2xy squared. And then that negative would cancel out the negative at the end and give you plus 2. To combine like terms, let's see what we have for matches here. I see we've got an x squared y squared and another x squared y squared. The coefficients of 3 and 6 would give us 9. And then we've got positive 2xy squared, but negative 2xy squared. They automatically cancel. Let's see, what else do we have here? I see we have a 6x squared, but nothing else, so we'll leave that. And then that constant at the end, plus 2. There's what you get when you subtract polynomials. When asked to multiply polynomials, you're going to do a lot of FOIL. And we've done this before, there's nothing new. But as exponents become bigger, they can become even greater in a product. So as we distribute, we just have to be mindful of the coefficients and the variables. Here's what I mean. Let's take a look at example A, 2m plus 5 in one parenthesis times 3m squared minus 4m plus 2 in the other. Now as we FOIL, I'm going to take the 2m and multiply it times 3m squared. The 2 times 3 becomes 6, and the m times m squared raises an exponent to m cubed. Distribute it to the next one, 2m times negative 4m. 2 times negative 4 would be negative 8, and m times m would be m squared. And then one more, 2m times 2, multiplying just those coefficients together, 2 times 2 is 4, so that becomes 4m. Now underneath, I'll take the 5 and distribute it in. I've got 5 times 3m squared, which would be positive 15m squared. So I'm going to write that right underneath the negative 8m squared, kind of keeping my like terms in check. The 5 times negative 4 would be negative 20m or minus 20m. And then last but not least, 5 times 2 is 10. So I'm just going to draw a line and add my columns together. That first term is 6m cubed. Nothing changes with that one. But in that second one, we have negative 8 plus 15. That would be positive 7m squared. 4m minus 20m, negative 16m. And then my constant stays 10. There's your product when we FOIL. Now the next example is even crazier. Not only do we have 3 parentheses, but we have m's and n's. So we just need to be careful how we write this out. What I'm going to do is just start with the first 2, and we'll do a FOIL there. If I take mn times another mn, both exponents go up to 2. That would become m squared n squared. And then if I multiply the outside, mn times negative 2 is negative 2mn. The insides, 1 times mn is 1mn. Ooh, that other n doesn't look that great. There we go. That's a little bit better. And then 1 times negative 2, negative 2. Like most FOILs, anytime you have terms in the middle, they're usually like terms, and we have that situation here. So we have m squared n squared. Nothing combines with that. But the 2 terms in the middle, negative 2mn plus 1mn, would be minus 1mn minus 2. So I'm going to put a big parenthesis around that, and then we have to take a look at that mn plus 4. So I'm just going to drop that down here, mn plus 4. And guess what? We get to FOIL again. I know, it's great. If we take mn, or m squared n squared, times another mn, we raise our exponents to m cubed and n cubed. And then if we take m squared n squared times 4, that's just 4 m squared n squared. Now that next term, the negative mn, if I multiply that by itself, that's going to be negative m squared n squared. And if we take negative mn times positive 4, that'll be negative 4mn. That last group, the negative 2, if I can distribute that to the other parenthesis, negative 2 times mn is negative 2mn, and negative 2 times positive 4 is negative 8. Once again, combining your columns with your like terms, our lead term doesn't have anything to combine with it. It starts off m cubed, n cubed. And then we have positive 4 m squared n squared minus 1 m squared n squared for a total of positive 3. Negative 4mn minus 2mn would be negative 6mn. And our constant is negative 8. And that's what it looks like to FOIL with different types of polynomials. Let's finish with some application. It says Carolina makes wind chimes to sell at a local street market. As Carolina produces a greater number of wind chimes, she can lower her price per unit. The functions v of x equal 48 minus 2x relates the price to the number of units that she produces. The cost C of making X number of wind chimes is represented by C of X equals 12X plus 64. So that's cost and then number of chimes. How many wind chimes should Carolina sell each week to maximize her profit? If we think about how much it costs to make them and then how much she actually sells them for, to figure out your profit, that's going to be how much she sells them for times the cost. So we have to be careful here. She sells them for 48 minus 2x. So that's the price per number of wind chimes. So to get profit, if we take price minus cost, this is where it gets a little tricky. The price is 48 minus 2x per wind chime. So we have to actually multiply it by x for the number of wind chimes. And then if we subtract out the cost is 12x plus 64. So trying to figure out her profit, if we distribute the x in, we would get 48x minus 2x squared. And if we distribute the negative in, minus 12x minus 64. Combining like terms and putting it in standard form, we would have negative 2x squared plus 36x minus 64. That would be the formula to determine her profit. Well, if we look at this, this is a quadratic function. We have negative 2x squared plus 36x minus 64. And if we want to, again, maximize the profit, and we're looking for how many wind chimes we need to sell, that would be looking for the vertex. And we spent a lot of time doing that. If we're trying to find x, how many we should sell, we just have to do the formula x equals negative b over 2a. If we were asked to find the profit, we'd have to plug that back in. But we're just trying to figure out how many we need to sell. B is 36, so with that negative out in front, it makes it negative 36. 2 times A is negative 2. We end up with negative 36 over negative 4. So how many wind chimes should we sell to maximize profits? We should sell a total of 9 wind chimes. We'll do that final problem tomorrow in class.